In this video, we'll learn details about linked list. What is a linked list? What is a node? Like nodes already I have shown you in the previous video. Then how to define the structure of a node and how to create a node, then how to access the contents of a node. We learn basic things about a linked list. So let us start with definition of a linked list. Let us define it, what it is. A linked list is a collection of nodes where each nodes contain data and pointer to next node. Data and pointer to next node. So linked list is a collection of nodes where each node contain data and pointer to next node. If you see this first node, its address is 200 and it is having data 8 and address 210. So this 210 is the address of this node. This is the first address of this node. So 210, this node is having data 3 and address 270. So this is the node whose address is 270. So every node is having data as well as link to next node. And first is a pointer which points on first node. We call this pointer name as first, or also we call it as head. Head is a pointer pointing to first node or head node. So this address is 200, so this is 200. And the address of pointer itself is 100. Now this linked list what I have shown you is similar to the one already we have discussed in the previous video, that linked list is created inside a heap, these nodes. And this first is a pointer pointing to that first node or head node. So the address of this pointer is 100. And these addresses, just I have taken them randomly. In real, when you create some memory in heap, that may be that addresses may be in thousands. But for making it simple, I have taken the addresses in hundreds. So these are just random addresses. Now one thing you can observe, in an array, all the addresses are contiguous. They are side by side. If this is 200, then this will be 202, like that. But here you can see that this address is 200, so this is 210, and this is somewhere else, that is 270, and this is somewhere else at 300. So all those nodes will not be side by side. Then how the continuity is maintained? Through links, that is addresses. So this is about a linked list. Linked list is created in heap. So I will remove this, then we'll talk about how to define a node, how to create a node. Now let us see how we can define a node. For defining a node, we have to define two things: data and the pointer. Data may be any type like integer, float, double, or any other type you can take. Then pointer is which type? Pointer is pointing to a node. That is next node. This is a node. So what is this then? This is also node. So pointer is of node type. Node is having a pointer of node type. So it's a pointer of its own type. Now let us define the structure of a node. A node is containing two members. Here is data and here is a pointer to next node. Let us call it as next. So this is node structure. Node is having data and pointer to next node. Then in programming, how we can define this structure? So for that, we can use a C language structure, struct node. Struct node. What are the members? Data. This is of which type? It can be any type, integer, float, double, or any other structure. You can take anything you want. But usually for learning purpose, we use integer. So I will call it as integer data. Then what is this? Pointer. Pointer to what? Pointer to a node. Then what is this? This is also a node. So this pointer is a pointer of a type node. Means the pointer of a type same node. So here struct node, pointer name is next. That's all. This is there in the structure. Now you can see that a structure is having data as well as pointer of type structure node only. So it's having a pointer of its own type. So such a structure is called as self-referential structure. Self-referential structure. Self-referential structures are famous, that are they are used in linked lists. So yes, we can see that they are useful in linked lists. For C language programming, we use a structure. For C++ programming also we can use a structure. C++ also supports structure. What is the structure in C++? It is same as class. Then what is the difference between class and structure? In class, everything by default is private, and in structure, everything by default is public. So if you are doing C++, if we are writing C++ program, then there also we can define a node with a structure only, or else we can use a class also. Now next thing, what is the size of the structure? So on this side I will write down, see this is integer. So we are assuming every time that integer takes 2 bytes. So let us say this is taking 2 bytes. And what about pointer? See, in any compiler, if integer is taking 2 bytes, pointer will also take 2 bytes. If integer is taking 4 bytes, then pointer will also take 4 bytes. So this is also taking 2 bytes. Total how many bytes? These are 4 bytes. So the size of a node is 4 bytes. It means this node is occupying 4 bytes. So the first byte address is 200 and the next byte is 201, 202 and 203. These are 4 bytes. And this node is also consuming memory 2, 10, 11 and 212 and 213. So every node is consuming 4 bytes. But for a pointer, just we need first byte address. So we are writing only first byte addresses. This is the size of a node. Now next, let us see how to create such nodes, how these nodes are created and link there. So linking part, creating a linked list, we'll see afterwards. First, let us see a basic thing, how a node is created. For creating a node, first of all, we need a pointer because nodes have to be created inside heap. So for that, we must already have a pointer. So I'll take a pointer. Struct node star p. I'm calling the pointer name as p. So when you declare any variable, this is a variable, pointer variable. So where the memory will be allocated? Inside stack. We know that this pointer is in stack. So anyway, I will just show it as a pointer. This is a pointer. Now I have to create node in heap. So for that, function in C language is malloc function. Malloc. How many bytes I need? Total 2 plus 2, 4 bytes I need. Now instead of giving that 4 bytes, I can even say what? Size of struct node. Struct node. This malloc function returns void type of pointer. So we have to typecast it of this type. So here I should write down struct node star. This is typecasting. So this is very lengthy code. This is how we do it in C language. But in C++, it's very simple. Say p assign new node. This node will be created. When we said new, it is created in heap. So we will avoid writing this lengthy code. I'll just remove it and I will keep this one. While writing the program, I may be typing this code. So we'll follow this code. P assign new node. A new node will be created. A node structure is defined with a data and next pointer. So this is data and this is next pointer. Suppose the address of this node is, for example, 500. Then 500 is there inside P. So it means P is pointing on this node. This is how a node is created. So we have seen how to create a node. Then how to access the members of a node. I want to fill some data and here I want to write address as 0. So I will write the data here. For writing data, P's data, P arrow data, like P is a pointer to a structure. So the structure members are accessed using arrow symbol operator. So I should say P's data, that is this one, assign with value some 10. So 10 is stored here. Then P's next assign with 0. So 0 means null. Null is stored here. So that is not pointing anywhere. So this is how we can access the members of a structure. This is how a node can be created. Creating a node and accessing the members of a node.